Explosion welding can accomplish what no other welding method can. Join nearly every kind of metal combination, no matter the type or composition. To create an explosion weld, two large pieces of metal are stacked atop one another, then covered with a high-powered explosive. When detonated, the downward force of the explosion welds the two pieces together through a combination of intense force and remarkable physics. The explosion welding process begins as soon as the two metal plates arrive at DMC's production facilities. To maximize the welding force of the explosion, the surfaces of each plate are ground as uniformly flat as possible, a process that also removes any rust, oxides, and other surface flaws. They are then ready to be assembled into the pack, which locks the plates into position for the explosion. To build a pack, the stronger and thicker of the two plates is laid face up. From now on, this plate will be identified as the backer. Small metal spacers of equal height are then tacked onto the surface of the backer in a uniform grid. These spacers will maintain a set gap between the backer and the second plate, which is placed on top. This second plate is thinner than the backer and is called the cladder. The standoff gap between the backer and cladder is less than an inch in height, yet without it, the explosion weld would be impossible. DMC uses an explosive powder that is a proprietary blend of common and unique explosive chemicals. The amount and exact formulation is always matched to the types of metals involved. Once the pack is set, the explosion is initiated at one end of the cladder and moves across the upper level of the pack at a uniform speed. This explosive front progressively drives the cladder plate downward toward the backer at the slight collision angle caused by the standoff gap. Forward of the collision point, air is forced out of the gap at high velocity. All oxides and impurities are expelled, rendering the plate surfaces metallurgically pure and ideal for a weld. As the backer and cladder collide, the weld is created nearly instantaneously across the entire surface of the plate. Not surprisingly, the power of the explosion can cause significant deformation to the newly formed clad. Therefore, upon its return to the processing facilities, the clad undergoes a final series of corrections. These include heating the clad in an oven that causes the metals to soften slightly. This relieves stress from the blunt force of the explosion's impact. Any bowing or misshapen curves are flattened out by either a 3 million pound press or, for thinner clad, by a series of rollers known as levelers. Finally, before the plates are shipped, stringent testing is conducted to ensure a solid weld between the two plates. Once the plates have been tested to meet exacting specs, it's ready to be shipped to the customer.